Hello everyone, this is DSS Zindabad and today we are going to discuss the daily challenge of Leetcode, which is group of anagrams. Let's jump into the problem statement. Given an array of strings, group the anagrams together. You can return the answer in any order. Now let's understand what is an anagram. So anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So for example, I was given something like TEA. The possible anagrams of this string can be ATE, right? Or it can be EAT. Basically, anagrams are nothing but the words which are there in the dictionary and which can be created from the string that has been given to me, right? So now what I have to do is I have already been given this string. I just need to group the anagrams together. So that here, as you can see in this example, I've been given a string and I've been given different strings in the vector. I need to group the anagrams together. And in the most simple terms, you can say that anagram of a string is the rearrangement according to the English dictionary, right? It should be a valid word. And it is a rearrangement in which the frequency of each character remains same. Okay. As you can see in the case here that we've taken, it was TEA. T was occurring once, E was occurring once, A was occurring once. Similarly, if you look at 8, we have A occurring once, T occurring once, E occurring once, and similarly for 8. Okay, now let's discuss the approach for this problem. The brute force approach that comes into my head is if somehow I could work with the frequency, right? I could use the concept of frequency. Now, how can I use frequency in this question? The brute force approach that is coming into my head is that what we can do is, if suppose I am standing on the 0th index, that means my current string in consideration is ETH. So I need to figure out the anagrams corresponding to this, right? What I'll do is I'll store it in a map. So my map M will have E having frequency 1, A having frequency 1, T having frequency 1. That means it's a character and frequency mapping. Now what I'll do, I'll run a loop from its very next index, that is 1 till the nth value that we have. And we'll figure out the frequency of each string. That means we'll be recreating another map, supposedly M1, and here next as we have T. So it will have T with one frequency, E with one frequency, A with one frequency. Then we can match these two maps, and if it is equal, I'll put it in my vector, right? I'll be creating a vector separately. I'll say that means it has T as its anagram. Then I'll go to the next one. That means on the second index, I've got a tan. So when this is added into the map, T occurs once, A occurs once, N occurs once. But now if you compare M and M1, these are not same. There is no E, whereas M has an E, right? And there is an extra N. So this will not be an anagram. Similarly, what will happen is once you figured out all the anagrams for each, you will go to the next index and again shrink the other half. That means you'll be having two nested for loops. So the time complexity will be n square, which is very high. I don't want to recompute it, and even the space complexity will be very high because we are using two different maps and each time a new map is being created and comparisons are being made. So this approach has a very high time complexity. What I need to do is I need to optimize it. Now, how can I optimize it? To optimize this, I have to, as I've already told you, we are going to use the concept of frequency of a character, right? So if I add on a twist wherein I say that as soon as you get a string, right, first you sort it. That means if you are getting S is equals to eat. You'll sort it and it will become AET. Now, why did I do this? I have done this because I want that my mapping should be created in a way that has less number of comparisons, right? So if you see, I'll copy paste this example. So if you see, if I start from the 0th index, what I'll be doing is, I'll say, I'm starting from here, right? I'll say you've got a string, right? First sort it. After sorting, you get AET. Now I'll create a map in which I'll store that my AET key has EAT in it, right? Next, when you go to the first index, you get TEA. So now you have TEA. Once you sort it, you will again get what? AET. So hence it becomes the key. As soon as you sort this given string given in the vector, you are creating a key. And as you got AET, it already exists in your map. You simply put this T here. So you will have another element added, that will be T in your map. Next, when you go to the second index, you get TAN. So if you sort it, you get ANT. Now this is not present in your map, a new entry is created. ANT has been created and corresponding TAN value is added to the map. You go to the third index, you get ATE, 8. So once you sort it, you get AET. This again matches here. So ATE is also added in this. Basically, this map will have string and vector string as its template so that you can store key as a string and its value correspondingly will be containing a vector of strings. Then as you go to the fourth index, you get NAT. Now once you sort it, you will have ANT again. ANT is present, so you will add NAT here. After that, you go to the fifth index, you get BAT. Once you have got BAT, you will sort it, you'll have ABT. Now ABT does not has already an entry, so you'll create an entry. You will have ABT is the key and its value is BAT. After that, you can simply use these, right? You can convert these into separate vectors and a complete 2D vector can be returned. This has a very simple time complexity. This is O of NlogN. Why is this? Because we are sorting it at every point of time and the for loop will be of O of N time complexity. So we'll give this the preference. I hope it was clear. Now let's quickly code this up and you'll understand how it's being done and why is this the time complexity. Okay, so let's start coding. First, let's create an answer 2D vector that we'll be returning, right? So as discussed, my first step will be to create the unordered map. We'll have the mapping of string and a vector that contains those strings, right? Let's name it M. Then what I'll do is I'll iterate over the string vector that has been given to me, right? I'll say strs dot size I plus plus, right? I'll create a string T which has the string that is present on the current index. Why am I storing this? Because I have to push it eventually, right? Into its corresponding value after it has been sorted. So now I'll say sort and I'll simply sort this value, right? So you can even write it something like, to make it easier, I'll say string s is equals to, let's copy paste this here and let's make t this. And now we'll simply say s dot begin and s dot end. This will sort the given string that I have. We've sorted s, so we'll push back t every time, right? Once we are done with this for loop, right? We have created the mappings. Now what I'll do is I'll just iterate over this for loop. I'll say I'll iterate over the map that has been created, which has the key as the string and the value as the vector of strings, which are the anagrams. I'll say iterator m, and I'll simply push them answer dot push underscore back, and I'll put the it dot second because it contains the vector strings that have to be returned, and then we can return the answer. I think we're good to go. Let's quickly check. Okay. So it needs to be an S. And it is working fine. Let's submit it. And yeah, it is working. So here in the code again, you can see that we have created an unordered map. So this will be storing all the unique strings that can be created from the given strings, right? And at max, in the worst case, supposedly there was no anagram present, right? So it will have the number of strings that are present in the vector. That means O of n as the space complexity. And if you look here in this for loop, you are running for O of n time, right? Because you are iterating over all the strings that are present in the vector. And alongside that, you're using the sort inbuilt function, which has a time complexity of O of n log n. And again, this loop runs for all the key value, the number of keys that are present in the map. I hope this was clear. We have already done a dry run for this question. If you still have any doubts, feel free to reach out. Thank you. Please like, share, and subscribe.